Alright, so we're talking about parallel lines, and parallel lines are two lines that lie in the same plane and it do not intersect. And this little symbol right here, okay, little mini parallel lines, is the symbol for is parallel. So you would read this as N is parallel to N. Okay, N is parallel to N. A transversal is a line that intersects two other lines in two distinct points. So this line right here is called a transversal. And these little arrows on these lines indicate that those two lines are parallel. So we know that N is parallel to N. And even if they didn't tell us that, if they showed us this in the picture, we could assume that the lines were parallel. And if that wasn't there, or they didn't tell us, then we couldn't assume. Okay? Alright. So, we talked about how some of these relationships would work out. We're going to give some of these angle pairs names. Okay? Now, some names that we're already familiar with are vertical angles, right? Okay? And our vertical angles would be like 2 and 4, 1 and 3, right? And what do we know about vertical angles? They're congruent, right? We also learned previously about linear pairs, right? What's a linear pair? Give me an example of one. 6 and 5, 1 and 2, 1 and 4. And what's their relationship? They add up to equal 180, right? Okay, so those relationships don't go away. Those are now part of our vocabulary, okay? And so we're going to add some new angle pair names when we have two lines cut by a transversal. And the first one is same side interior. And these names, to me, go just exactly with what they do, okay? So same side interior would mean they're on the same side of the transversal inside the parallel lines. So my same side interior would be angle 4 and angle 6 and angle 3 and angle 5. So angle 4 and angle 6, angle 3 and angle 5. Those are same side interior. Then we have what's called corresponding angles. Okay, and corresponding angles are on the same side of the transversal, on the same side of the parallel lines. For example, angle 1 and angle 6, those are corresponding. They're both to the left of the transversal, above the parallel lines. Yes? Oh, I forgot to get that to you. Okay. So, 1 and 6 are corresponding. They're to the left of the transversal, above the parallel line. So what would be some other corresponding angles? Okay, 3 and 5, no, those are same side interior. 3 and 7, because they're to the right, below the line. Okay, so angle 3 and angle 7. Okay, give me another pair. There's 4 pairs of corresponding. Angle 2 and angle 5. And there's one more pair. 4 and 8. Alright, so those are my corresponding. Same side of the transversal, same side of the parallel line. Alright, then we have alternate exterior. And alternate exterior are on alternate sides of the transversal, outside the parallel line. So, on alternate sides of the transversal. One on one side, one on the other side of the transversal. So that would be 1 and 7. And what would the other pair be? 2 and 8. Okay, and then we have alternate interior. And those would be on alternate sides of the transversal, inside the parallel. Okay, so what would that be? Angle 4 and angle 5. And what? And angle 3. And angle 6. Now, these angle pairs would have these names regardless of whether the lines were parallel, okay? But these angles have relationships with each other that only happen when the lines are parallel, okay? And so that's what we're going to talk about here in just a few minutes. Now, what if I asked you this question like this? What if I said, which angle pairs include the names of the angle? I wrote that down wrong. Which angle pairs include this particular angle? Okay, I don't know what I was supposed to write there. I didn't type it right. So angle 4 is a pair with what? Okay, so with angle 6 and y, what kind are they? Same side. Okay, so same side with 6. Okay. What else? Alternate interior with what? What angle? 5. So alternate interior with angle 5. Okay. And you said corresponding. What's it corresponding with? And with 8. Okay. So it's corresponding with 8. Okay. And then it's vertical with 2, and it's got some linear pairs in there, but those are the main ones for this particular lesson. Okay. What about angle 7? It's alternate exterior with 1. So alternate exterior with 1.
Corresponding with 3.
Okay, and it's corresponding with 3. Good. All right. Now, here's the relationship. We talked about these just at the very, very beginning when I was showing you that one parallel lines. If a transversal intersects 2 parallel lines, then same side interior angles are supplementary. Okay? So we see here that 1 and 2 are same side interiors. And this postulate tells us that they are supplementary with each other. Okay? So anytime you have a pair of same side interior, they're always going to add up to equal 180. How can you express each of the numbered angles in terms of x? Okay, so this angle right here is x, and I want to express all these other angles in terms of x. Okay, so what would we start with? 6. Okay, what would 6 be? What did you say? I heard it. 22. No. Oh no, I'm not answering this one. I'm naming it in terms of x. So if this angle here is x, how would you represent 6 in terms of x?
Plus x.
What did you say? 180 minus x. Okay, 180 minus x. All right? So then how would we express 7? 7 would be x. What about 8? 180 minus x. Okay? So here, this is x. What about 3 or 2? Either one. Let's do 2. What would 2 be? 180 minus x, because it's same side and they're supplementary. They add together to equal 180, which then means that 3 would be what? X. And 4 would be 180 minus x, and 1 would be x. So if you have parallel lines cut by a transversal, if you know one angle, you know all 8, okay? If the lines are parallel cut by a transversal. All right? So let's put a number in here. Okay? Let's say that angle 4 is 118. Okay? And I want to find the measure of all the other numbered angles. So if angle 4 is 118, what's angle 2? 118. Okay? And angle 1 then would be what? 62. So that'd be 180 minus that, which means angle 3 would be 62. Okay? What about x here? 62. Because these have to be supplementary. X and 2 have to be supplementary. Okay, what about 7? 62. What about 6? 118 and 8. 118, right? Okay, so our postulate told us that our same side interior were supplementary, yes? Okay, what can we say about our alternate exterior? Our alternate exterior. What relationship do they have? They're congruent, aren't they? Isn't 4 and 6 alternate exterior? And they're congruent, as is 1 and 7, right? What about alternate interior? Like 2 and 8. They're congruent, right? As is x and 3. What about corresponding? What's a pair of corresponding angles? 2 and 6. And what relationship do they have? They're congruent, as would be 4 and 8, right? 3 and 7. and 1 at x, right? Okay. So it looks to me like we know the same side interior are supplementary, yes? We discovered that the alternate interior are congruent. The alternate exterior are congruent, and the corresponding are congruent, right? Okay? Which leads us to our theorems, okay? We have the alternate interior angles theorem that says that all alternate interior angles, if they're parallel lines cut by a transversal, are congruent to each other. If we have corresponding angles, parallel lines cut by a transversal, they are congruent to each other, okay? And likewise with the alternate exterior. If you've got parallel lines cut by a transversal, then your alternate exterior angles are congruent to each other, okay? You need to know these. This goes into your vocabulary that you started with the first chapter, all right? You need to be able to recognize these and know their relationship, okay? One thing, people that didn't do maybe as well on the test as others don't know the relationships yet. Some of us still don't know that vertical angles are congruent and that linear pairs are supplementary, okay? And some of us really don't know the congruent supplement, the congruent complement theorem, and the difference between that and the transitive property, okay? So people that are struggling, this is why they're struggling, because they have not put this vocabulary into their brain yet, okay? They're not speaking the language yet. All right, so we're going to prove the alternate interior angles theorem. And if we're proving the alternate interior angles theorem, we can't use that reason to prove, okay? So we're going to start out with the fact that M is parallel to N. Okay, M is parallel to N. And we want to prove that angle 1 and angle 2 are congruent to each other. Those are the alternate interior angles, okay? But we have to work our way there. Yes? What do you see here? What relationships do you notice? 2 and 3 are a linear pair, right? Which means they equal 180. They're supplementary, they equal 180. So we can say that the measure of angle 2 plus the measure of angle 3 equals 180. And that is the linear pair theorem. Okay? All right? So we know that 2 and 3 are supplementary. Does 1 and 3 have a relationship? They're supplementary because they're what? That was the first postulate that we learned. We can use that in this proof. Same side, interior angle postulate, okay? So we can also say that the measure of angle 1 plus the measure of angle 3 equals 180. And that is the same side, interior angle postulate. Okay, so what do I notice about both of these sums? Huh? They both equal 180. And when you've got two things that are equal to 180, what can you do? Set them equal to each other, right? Okay, they're both equal to 180, so they can be equal to each other. So you can do the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. What would that be called? Yes? You would, but you would have to, there would be another step in there. You could, yes. Yeah, you could. You would have to state they were supplementary. You would have to state that 2 and 3 are supplementary and 1 and 3 are supplementary. And then you could say that 1 and 2 were congruent. Yes, you could. I didn't think about that. All right, so but we'll go with this way and we'll talk about that, okay? All right, so what would this reason be? No? They're both equal to the same thing, so they're equal to each other. What is that? Elijah? You could use congruent supplements. I didn't even think about that. That's what he just said. We'll talk about that in just a second. But I see why you're saying that for this transitive. That's what I'm looking for. When two things are equal to the same thing, you can set them equal to each other by transitive. Okay, I'm going to come back to the congruent supplements theorem here in just a second. Okay? Is your question?
No, I was going to say.
So what would we do next? Subtract the measure of angle 3 from both sides. Okay? So that would give me the measure of angle 1 equals the measure of angle 2 by subtraction. Okay? And then what would I need to do? Change it to change it. And that would be definition of congruence. Okay, so there was a question right here. Somebody said, well, could we have used the congruent supplement theorem? I didn't even think about it, but yes, you could, okay? Once you stated that these two were equal to 180, then your next step could have been angle 2 and angle 3 are supplementary, and angle 1 and angle 3 are supplementary. Okay? And that would get by the definition of supplementary angles. And then you could have said that angle 1 is congruent to angle 2 by the congruent supplement theorem. Okay? And that would have shortened your work just a little bit. Okay? You could have done it that way as well. Okay? Most of us struggled with this on the test. There was a question like this on the test, and most of you said that these were supplementary. That's not right. Okay, they're congruent. If you've got these two supplementary and these two supplementary, they're both supplementary to the same thing, so they're congruent to each other by the congruent supplement. Alright, so now we can use that theorem I was just proving. Because remember, every theorem has proof to back it up. Okay, that's how we get all these rules. This mathematician came up with these theorems and proved them to us. Alright, shapes with parallel sides. Okay, we have our trapezoid, and we have our parallelogram, and we have our trapezoid that have some parallel sides. Your parallelogram has two pairs of parallel sides. Notice that I've got a single pair of arrows, and I have a double pair of arrows. Okay, that means that the two across from each other are parallel. Okay, there's more than one set of parallel lines. So when you work these problems, sometimes it's helpful to highlight the parallel lines in the transversal. For example, see these two angles right here? This line and this transversal are what create those angles, okay? So if I highlight them, they kind of pop out. Okay, so now what kind of angles are they in regard to the parallel lines? Same side interior. And what do we know about same side interior? No, they're not equal to each other. Look at them. One's obtuse, one's acute. Okay, they add together to equal 180. Okay? So we can do 6x plus 2x plus 4 equals 180. So we end up with 8x plus 4 equals 180. Subtract 4 from both sides. And then divide both sides by 8. And x is what? 22. Okay? So x is 22. They also want us to find the measure of angle A, the measure of angle B, the measure of angle C, and the measure of angle D. Okay? So to find A, we go back and plug in. 6 times 22 is what? 132? Okay, I'm believing this. Everybody agree? Alright, so 132. So this right here is 132. I could do one of two things here. What could I do to get B? Just to 180 minus 132, that'd probably be the easiest thing. So what would that be? 48? Okay. So this right here is 48. Okay. Now, we have to use a different pair of parallel lines now. Okay? Now, we're working, let's say, with these two parallel lines and this transversal. Okay? Yes? Right. Angle C would be 132. And then, again, we would, use a different pair of parallel lines, and D would be what? 48. When we study parallel or quadrilaterals, we're going to learn a theorem that says opposite angles of a parallelogram are congruent. Okay, that's a theorem. Yes? The same side? That's what I said. Yeah, the same side interior. Yeah, you're right. I think that's what I said. I don't know what I said, but I think that's what I said. Okay, all right. Now, if you come over here and look at the trapezoid, you only have one pair of parallel lines, but you have two different transversals. Okay, you have this one, and we can find y with it. And then you've got this one, okay? Alright, so if we wanted to, let's find x first. What would we do to find x? Okay, add them together, it's an equal 180. So 3x plus 2x equals 180, which would be what? 5x equals 180. Divide both sides by 5, and we get, what, 36 for x, okay? So x is 36, which means 2x is 72, and 3x would be either 36 times 3 or 180 minus 72, which is 108. Okay. Now, I can't do same side interior here because these transversals are not parallel, all right? So now I have to come over to my other pair of parallel lines cut by the red transversal, okay? And so what would I do to find y? Add those together, so y plus y minus 10 equals 180. So that gives me 2y minus 10 equals 180. Add 10 to both sides, and then divide both sides by 2. And so that ends up being 95. Okay, so y is 95, which means the other one's 85, right? Okay. All right, questions on that? Okay. Last one. Well, there's two here, actually. The white trim shown for the wall of the barge should be constructed so that AC is parallel to EG, JA is parallel to HB, JC is parallel to KG. What should angle 1 and angle 3 be? Okay, so I'm going to highlight these in colors over here, and then we're going to work with the one that's not so frou-frou, okay? So, AC needs to be parallel to EG, okay? JA needs to be parallel to HB, and JC needs to be parallel to KG. Okay? So those are my parallel lines, alright? Now, I want to come over here and I want to figure out what angle 1 and angle 3 should be. Okay? And sometimes, like I said, it helps to highlight the lines that create the angle. Okay, so if I look, angle 1 is created by this line and this line, right? And we know that this line is parallel to this one, correct? So what kind of relationship do 68 and angle 1 have?
Equal 180.
They equal 180, right? So to get the measure of angle 1, I'm going to do 180 minus 68, which is going to be what?
112.
112. Okay? So the measure of angle 1 is 112. Okay? Now I need to work my way over to 3, right? Yes. What did you say? Okay. No, they're not. What's alternate exterior? The 1 and the 3? No. Let me show you why. Okay, let me erase this. If I looked at angle 3, it takes these right here, right? Let's look at this right here, because these lines right here are supposed to be parallel, right? Cut by this transversal. I can find this angle, right? What relationship do these two angles have? They're same side interior, right? So they're supplementary. So if this is 112, this is 68, right? Okay? And then this is what relationship right here? They're vertical, right? So the measure of angle 3 is 68. Okay?
From 68 up by A plus angle 3
So, is that what you, that may be what he was trying to say, and I just, so, this 68, look at this, no, alternate exterior, I don't think so. Now, you could have, another thing you could have done is you could have looked at these two lines cut by this transversal, and these are corresponding. Oops, wait. This line and this transversal, those are corresponding. Okay, so you could have got 68 here, and then look at, oh my goodness, and then I could have looked at this line and this transversal, and those are corresponding. So I could have done it like that. That was another way you could have gotten to it. Okay? But I don't see an alternate exterior there.
That makes sense. 68 one,
Okay. Yeah. Okay. So, we've got one more to do here. Okay. EJF is 56 degrees. Okay. We want to find FHK. FHK is this little angle right here. Alright. So, let's see. Might have to work our way there. Remember our parallel lines, okay? We have this line, We also have these two lines that are parallel. What did we find here?
It's the 3B68, isn't it? That
No, 68 no longer is in play. New problem. Okay? Because this is what we're doing now. EJF is 56. What were you going to say?
EJ and FH are parallel.
Okay.
The line that goes through them is JF.
Okay.
And I was going to say that they were alternating.
Okay, so this one right here?
Yeah.
Yes. This one right here. These are alternate interior angles. Okay? So they're congruent. Is that what you're saying? Okay?
JF and KH are parallel.
Mm-hmm.
And they're cut by FH. So then maybe say something.
And then we got same side interior right here, right? So that would make it, what, 124? Good. Good. So he did alternate interior here, okay? And then he did same side interior with the 56 and the 124. Okay? When I did it with my other hour, we found a whole bunch of other angles till we got there, and that's okay. Sometimes, you know, you don't get directly there, but once you get there. Alright, any questions? We talked about several sets of angles that are created when you've got two lines cut by a transversal, and we talked about what their relationships were. Okay? What about 1 and 6? What kind of angles are those? They're corresponding, and what's the relationship if the lines are parallel? Wait, what is the relationship with 1 and 6 if the lines are parallel? They're what? They're congruent, okay? How about 4 and 6? You said 4 and 6. Those are same side interior. And what's 4 and 6's relationship? They equal 180, okay? What about 1 and 7? Alternate exterior. And what's their relationship? They're congruent. And then we've got 4 and 5. Alternate interior. And they are congruent, okay? So our congruent ones are our alternate interior, alternate exterior, and corresponding, right? And our supplementary ones are our same side interior, okay? And then don't forget about vertical angles and linear pairs, okay? All right.